This is the third set of notes in the ocean unit, the oceanography unit, some may call it. And this is called Ocean Facts. This is going to be the last set of notes in oceans as well. Write down everything that's in orange text, either handwritten or typed, or you can use my fill in the blank option. So, things to know about the ocean. 75% of the Earth is covered in water. Most of that is in the ocean. And there's 5 major oceans: the Atlantic, the Pacific, the Indian, the Southern, and the Arctic. Waves are caused by wind. If you've ever been to the beach, you've probably noticed waves lapping at the shore. Normal waves are caused by wind. The larger the body of water is, the bigger the waves will be. Oceans are the largest body of water on the planet, and the waves reaching the beach can be quite big, like the ones people like to surf. I think this is in Hawaii, where there's lots of ocean between land there, and the waves get pretty big. But there's different kinds of waves besides your regular beach waves. There's something called rogue waves. These happen in the open ocean, and they're much larger than the surrounding waves. They used to be thought of as a myth, but recently have been scientifically documented. There's also tsunamis. A tsunami is a giant wave that happens in response to an earthquake, a volcanic eruption, or meteor impact. So that would be a case where wind isn't causing a wave, but it's a special kind of wave as a tsunami. And then there's this area in the Southern Ocean at 40 to 50 degrees south latitude. There are very strong winds and no continents to block the wind flow, so waves get rather big down there, and the wind blows pretty hard. We looked at this picture during the last art project. This is a picture, painting of a tsunami. And this is the aftermath of a tsunami in Indonesia, I believe. Why is the ocean salty? Well, there is the erosion of minerals coming from land, and then the constant evaporation of water from the surface of the ocean that leaves minerals behind. And minerals are also released by underwater volcanoes and something called hydrothermal vents, which you see a picture of here, and we'll talk about a little bit later too. The salt in the ocean is mostly NaCl, so sodium chloride. That's normal table salt. So obviously, ocean water is salt water, and then river water is fresh water. Where the two meet, it's called an estuary. In estuaries where salt water meets fresh water, salt water wedges underneath of the fresh water because it's denser. Always remember that salt water is denser than fresh water, and salty water sinks below fresh water. Estuaries are places that are known for lots of biological productivity, in part because you have saltwater organisms mixing with freshwater organisms in the same ecosystem. A little bit about the tides. We did talk about the tides in the astronomy unit, but I'm going to cover them a little bit here. Tides are the periodic rise and fall of water level in large bodies of water. Tides are caused by the gravitational pull of the moon and the sun. And the tidal range is the variation between high tide and low tide. And the tidal range can change based on the phase of the moon. Spring tide happens at new and full moon, and those have the largest tidal variation, so the highest high tide and the lowest low tide. Neap tides happen at first and third quarter moons, so like your half moon looking from Earth, and those have less tidal variation. So spring tide, full and new moon, has the highest high tide and the lowest low tide, a more extreme tidal variation for the spring tide and a less extreme one for the neap tide. Photosynthesis in the ocean. The ocean is teeming with life, and we're familiar with lots of charismatic ocean organisms like fish and dolphins and turtles and such. But much of the life that exists in the ocean is actually microscopic. Small, single-celled, photosynthetic organisms called phytoplankton, or algae, make up a large part of the ocean's biomass, like the total amount of living things in the ocean. A lot of it is phytoplankton. Through photosynthesis, marine phytoplankton, that's ocean phytoplankton, contribute over 50% of the oxygen found in the atmosphere. So we're relying on the ocean for the oxygen that we breathe. The other part of photosynthesis, besides expelling oxygen, is taking carbon out of the atmosphere and turning it into sugar. That's how phytoplankton and plants on land make their bodies. Marine phytoplankton take carbon out of the atmosphere, and thus the ocean is a carbon sink. That means it stores lots of carbon that would otherwise be sitting in the atmosphere and contributing to the greenhouse effect. And there's a food web down there, and the carbon moves around. As carbon works its way up the food chain, much of it ends up being used as exoskeletons and seashells. Ultimately, this carbon sinks to the bottom of the ocean floor when organisms die, and it's buried for sometimes millions of years. So that's like a really long time for carbon to be stored, and that's a good thing. The ocean absorbs lots of radiant energy from the sun. The ocean is sometimes called the largest reservoir of heat at Earth's surface. This heat is a major driver of climate and weather, and if you live near the ocean, you're going to experience a milder climate on average. So living near the sea means that you'll have like cooler summers and warmer winters than if you live in the middle of a continent. As you can see on this map, like Calgary, for example, is roughly at the same latitude as Vancouver. But Vancouver's on the sea, or on the bay at least, so Vancouver is going to have milder temperatures in general than Calgary. And Calgary is going to get colder in the winter, and it's going to get hotter in the summer. And that's from the energy stored in the ocean. We did a whole set of notes about the global conveyor belt. The ocean currents, warm and cold, those can also influence the climate in a particular area. So if there's a warm ocean current flowing by an area, that's going to make the temperatures in that area a little warmer. If there's a cool ocean current flowing by, that's going to make the temperatures a little cooler. And here's a map of your ocean currents, including the warm currents in red. You notice those are moving either north or south away from the equator, carrying energy, heat from the equator towards the poles. And then you have the blue currents, which are carrying cool water towards the equator. So it's about the movement of energy. Humans in the ocean. We depend on the ocean for transportation, recreation, food, mineral resources, and oxygen production, as I already mentioned. So the oceans are important to people. However, we do harm the ocean by overfishing, pollution, and burning fossil fuels. Burning fossil fuels leads to ocean acidification. Pollution can include everything from oil spills to microplastics, tiny little pieces of broken down plastic that end up inside of fish and eventually inside of us. Lots of pollution starts on land and is carried to the ocean by the water cycle. One last thing on this set of notes is hydrothermal vents, which I mentioned earlier. These are part of why the ocean is salty. They're expelling minerals from inside the earth. In the deepest parts of the ocean, near a plate boundary or a hotspot, you've got geological features called hydrothermal vents. And these are chimney-like structures that expel hot water and nutrients. And these hydrothermal vents tend to have like a whole ecosystem surrounding them, even though there's little to no light that reaches them. So usually the bottom of a food chain would be photosynthetic organisms that depend on the sun for their energy, and then fish would eat that, and then bigger organisms would eat that. But there's the bottom of the food web near a hydrothermal vent is actually chemosynthetic, which means it depends on the energy stored in chemical bonds for the base of the food chain, which is very interesting stuff. Here's a picture of a hydrothermal vent that includes one of the organisms that lives nearby. These are tube worms, and they are stationary organisms that are chemosynthetic. So here's what the notes will look like if you type them up all on one slide. Of course, you can handwrite them and photograph them. Either way, it goes in your notebook. And of course, you can go back and watch the video as many times as you need to.